Welcome members, today we are going to see more about binomial theorem. But please don't forget to subscribe to the channel. Now, we are going to see how do we handle this question. Now, the question says, show that if x is so small that the cube and higher powers are neglected, then that expression is that. Now, to neglect other powers, it means that we are like the cube powers, then the power 4 are going to be neglected, so we are not going to consider them. Now, do we know how the binomial theorem is? The binomial theorem states that if you have such a bracket, this is how you can expand it. You expand it up as many as you want. But now I'm just stopping at this for my example, stopping at this, but you can expand up to x power 4. Now, you want to show that now the cube powers are neglected. So the cube powers and above are neglected. That's why when I'm writing my formula, I'm ending at x squared, because these powers, the cube and the higher powers, power 4, power 5, for them are neglected. Now, in the binomial now, if I have this, there are many ways of doing this. You can either expand this. You see this square root is the same as all of this power half, and this one also power half. Then you can take it up, and then you expand this and then after you multiply. But that one is a longer method. The shorter method is you always make this to be the one that is going to multiply this. So you want this to be 1, like to power 1. So you expand to make it power 1. So this one is the square root. So you need a square on the whole of this. So it means that you are going to create another bracket similar to this. But because it's not there, you multiply it up and down. So when I do this, I get this power. But here I set the place of the squares. So now this, the whole of this root is on this and this. So this square, and then the square root is the same as a half, and then the whole of this, we have our half there. So now, if we take now this is going to cancel, you have 1 plus 1 minus x. Then when I take this up, the positive will come to negative. Now you see that I can expand this and I easily multiply. So now I'm going to consider this. So if I consider now 1 minus x squared and negative half. Now I'm going to compare it with this one. So you see, if I compare it with 1 plus x power n, you see that from there, if I compare the two, my n is negative half. This and this, that your x is the same as negative x squared, and 1 is 1. So meaning, now we come and expand this x squared, the whole power negative half, equaling 2. Now we are putting in this formula. Why am I stepping like this? Because they told us that the cube powers and higher powers are neglected. That's why I shortcut x squared. So 1 plus n, my n is negative half, into now x, my x you see, negative x squared over 1 factorial, then plus n, my n is negative half, then n, which is negative half, minus 1, then x, negative x squared, the whole over 2 factorial, plus other terms coming. You always include this so that there are other terms still coming. Okay, let's simplify this and see. Now we have 1 minus x squared power negative half equaling to 1. A negative will give us a positive x squared. Then this 2. 1 factorial is 1. Then we have then plus, or is this factorial to factorial, or is our 2 factorial is 2. So remove this as a fraction. So remove it as 1 over 2. The whole of this into now negative 1 over 2. When we simplify this, it's that we have negative 3 over 2. Then the whole of this was squared because x was squared. So when I square this, first of all, I'm going to get a positive, then x power 4 plus other terms coming. So let us simplify and see. Now r1 minus x squared power negative half will be 1 plus x squared over 2. Then this negative and this negative will give us now a plus. This negative and this negative give us a plus 3, the whole over 2 times 2, 8, then x power 4 plus other terms coming. Now, they told us that the powers above 3 and then negative, meaning that now we have 1 minus x squared power negative half equaling to 1 plus x squared over 2 plus 3 over. So this one I'm going to neglect it because those powers we neglected them. That's why I'm adding this. But now the whole of this is this. But remember, the whole of this is equal to this times this. So now I come to this. It's going to be 1 minus x into, which will be, now we have seen this one is 1 minus x. Then the whole of this is this. So 1 plus x squared over 2. Then plus other terms. So we can expand it. This time this we get 1 plus this time this. Then this time this we get negative x. Then this and this we get plus. Negative. Get negative x cubed over 2 plus. But we say we neglect cubes and so on, so we are going to neglect this. So that now, if I neglect this, the whole of this now, the root. Remember, the whole of this is equal to this. So now, I have 1 minus x over 1 plus x equal to, now 1 minus x plus x squared over 2 plus other terms. I neglect this one, because the question said so. So, understand that's the proof we have to show that. Then using x equal to 1 over 8, show that that is true. We are just going to put into that formula. So now, we are putting that our x is 1 over 8. If we put it here, we shall be having now the square root of 1 minus 1 over 8 over 1 plus 1 over 8 equaling to 1 minus, where is x? We are putting 1 over 8, then plus, this will be 1 over 2. So we can simplify. See that when I cross multiply here, I'm going to be having now the square root of, this will be 8. Okay, I have 8 minus 1 over 8. I'm dividing it with, this will be 8 plus 1 over 8. That's what I have in brackets. Dividing. This side, you say I have plus, this will be 1 over, this will be 64 times 2, that's 128 plus other terms. Now you start, this one is going to cancel. So up, I'll be having roots. So that this cancel with this. So I have 8 minus this, I have 7 over 8 plus 1, that's 9. Now I'm going to say approximate 2. I'm going to ignore. If you say approximate, you ignore now these ones. So the LCM the other side is 128. So this goes here. 128 times this, so you have 128, then minus 8 goes into that how many times? I think 16 times. 8 goes here, I think 16 times. Is it 16? Yeah, 16 times. Then plus this one goes here, I think 1. Then we just simplify, this will be root 7, square root of 9. 3 approximately. Now let me get for you. Okay, to sum up that for you. So you get 128 plus 1, then minus 16. The answer you get there is Is it, the answer we get here is, okay, the answer we get here is 113 over 128. Now I need to multiply through. So if I multiply through, if I multiply through, now the square root of this, I'll be having the square root of 7. If I multiply through by this 3, I have now 7 approximating. Maybe if you check to see, you have 120, so maybe there is a small weight, a little bit. Okay, so members, if you multiply this and this, we shall be having this times this 3 multiplied to the side. We have 113 times 3, which will give us 339 over 128. And from there I see, and now our root 7 is going to approximate 2. Is that if you divide that one, the answer you get is 339 divided by 128. So that the answer we get is 2 whole numbers, then the remainder is 83, the whole over 128. So members, that's how we handle these numbers. I think you see it's that proof they want you guys to do. Don't forget to subscribe to the channel. I wish you the best. Go through more of the binomial numbers there.